Welcome to my Pre-Algebra review series. This video covers Chapter 5, Section 2, titled Fractions and Decimals. By the end of this section, you will have reviewed the procedures for writing fractions as decimals. This will include writing a repeating decimal and ordering fractions as decimals. Additionally, you will end these activities by writing decimals as fractions, including writing repeating decimals as a fraction. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and certainly it will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. So let's get into it. Objective 1. Writing fractions as decimals. You can write a fraction as a decimal by dividing the numerator by the denominator. When the division ends with a remainder of 0, the quotient is called a terminating decimal. The picture here denotes a terminating decimal because this ends right here at 0.625. This is our quotient. It ends right at the 5. It goes no further because our remainder is 0. But let's take a look at how we did this long division. I'm sure you all remember doing long division. So let's just take a look at it. So we're taking 5 and we're dividing it by 5 and we're dividing it by 8. That's what it says. Okay, take the numerator, divide it by the denominator. So in our case, we put the numerator inside and we divide by 8 on the outside. And let's just run through it. Let's practice here one time. 8 divided goes into 5 how many times? 0. So we put the 0 up top, and we're going to put our decimal point right here because this is where the decimal place is. So right there is the decimal place. We're going to put it right there. 0 times 8 is 0, so there's nothing much we can do. So now the next one, we pick up now the 50, the 5 and the 0 next to it. We say 8 goes into 50. How many times? Oh, 8 goes into 50 6 times. So we write the 6 right here above the 0 because 6 times 8 is 48. So we're going to subtract the 448 or the 4.8 in this case, but we're not going to worry about the decimal place. 48 and we get a 2. Here's the 2. Okay, so now we see, well, the 8's not going to go in the 2. We bring down a 0. So once you do the subtraction, you bring down the next 0. So now you say 8 goes into 20. Does it? Yes. How many times? 8 goes into 20 2 times. So we write the 2 on the top. 2 times 8 is 16. Here's the 16 right here. And we subtract it from the 20. We get a 4. So now 4 is less than, obviously it's going to always be this way. It's going to be less than 8. So we're going to bring down the next 0. So now the 4 becomes a 40 right here. And 8 goes into 40 how many times? 5 times. 5 times 8 is 40. So we're going to subtract the 40. So 40 minus 40 is 0. So our remainder is 0. So this is the answer. Our quotient is 0.625, and it is a terminating decimal. So the division process of 5 divided by 8 ends with a remainder of 0, right here, and therefore the 0.625 is a terminating decimal. Okay, example 1. It's a real-world problem. It says a customer at a delicatessen asks for 3/4 of a pound of potato salad. The scale reads 0.75. Is this customer getting the amount of potato salad she requested? And explain, it says. Well, let's try it. So in order to figure this out, we've got to convert the 3/4 of a pound. 3/4 of a pound has to be converted to a decimal number. So in order to do that, what did we just learn in the previous slide was you take the numerator and you divide it by the denominator. So 3 divided by 4. So here's our problem. And we're going to divide 3 by 4. So does 4 go into 3? No. That would be 0 here, right? So no is the answer. We're going to put we have a decimal place right here. We're going to put a decimal place right there. And we're going to put a 0 right here. Okay? So now does 4 go into 30? Yes. How many times does 4 go into 30? 4 divides into 30 7 times. 7 times 4 is 28. And you subtract the 28 and you get 2. 30 minus 28 is 2. So now we still have a remainder, so we bring down another 0. We add a 0 up here and bring down a 0. 4 goes into 20 how many times? 5 times. Okay, I'll put this out a little longer. 5 times. 5 times 4 is 20. We subtract the 20 and we get what? 0. So this is a terminating decimal. Okay, 0.75. There's 0 remainder. And what did the scale read? So it read 0.75. And our answer is 0.75. And so they are equal to each other. So yes, the amount of potato salad she requested is correct. And we explained by showing that the 0.75 is equal to 0.75. Okay, example 1, under check your understanding. As we've done in the past, I'm going to say go ahead and stop the video and try these on your own and see what you come up with. Come on back, and when you come back, we'll work them together. Okay, now that you've done that, we're going to go through these problems. There's 4 problems here. It says write each fraction as a mixed number or as each fraction or mixed number as a decimal. So let's start off with the first one. So the first one here is 1/4. So we want to write 1/4 as a decimal. So what do? Well, we learned that we take the numerator, and we divide it by the denominator. And I'm going to put a point, because we already see that the numerator is smaller than the denominator. So I'm going to put a decimal point here. I'm going to put one here. I can add a 0 here if I want already. Okay? I can add a couple zeros if I want. I can add as many zeros as I like. So 4 goes into 1? Nope. Just so we got a 0 here. Does 4 go into 10? Yes. How many times? 2 times. 2 times 4 is 8. 10 minus 8 is 2. Bring down the 0. Got to bring down the 0 because the 2 is a remainder. And it's not a 0 remainder. So you bring down a 0. And we're going to divide by 4. 20 divided by 4 is how much? 5. 5 times 4 is 20. We subtract the 20 and we end up with a 0 remainder. Okay, so write each fraction or mixed number as a decimal. So the answer to this is, we could say 1/4 equals 0.25. Okay, so let's do the next one. 1 7/8. So we don't have to do anything with the 1 here. So we can keep the 1 by itself momentarily. So what we're going to do is we're going to take and find the fraction. So that's 7/8. We're going to have 7 divided by 8. Okay? And we're going to put a decimal point right here, and there's a couple of zeros because we know something's going to happen. We know something because we got to get the 8 is larger than the 7. So does 8 go into 7? No. So we could put the decimal point here and say 0. Excuse me. Excuse me. Does 8 go into 70? Yes, 8 does go into 70. How many times does 8 go into 70? Well, 8 times 8 is 64, and 70 minus 64 is 6, so we know it's going to go in here 8 times. So we have an 8. 8 times 8 is 64. Minus 64 was going to give us a 6. Bring down a 0. 8 goes into 60. How many times? It's going to be 7. 7 times 8 is 56. Minus 56 gives us 4. Right? 60 minus 56. Bring down a 0. 8 goes into 40. How many times? 5 times. 5 times 8 is 40. 40 minus 40 is 0. So we have a 0 remainder. That means this is a terminating decimal. And our answer is exactly right here. I'll write it over here as 0.875. Okay. This one over here was 0.25. Oh, and we've got a 1 to put in front of it. Excuse me, everyone. I jumped the gun on this one. We have a 1 that we have to put in here. So the real answer is 1.875. We have to add the integer value here that we've pulled aside, and then we tack on the decimal point, the decimal part of it. I'm very sorry about that. I have to remember it on this next one, C, about doing that. That the 3 is still there, so we're going to pull the 3 aside, right? And then the number is 3 divided by 10. And I'm going to put a point and a couple of zeros. I can put as many as I want. I'll put a couple. I don't know how many I need, but so 10 and goes into 3? Nope, I have a 0 right there. So does 10 go into 30? Yes. How many times does 10 go into 30? It goes in 3 times. 3 times 10 is 30. Bring down the minus 30. 3 times minus 30 gives us 0. So there's the answer. Our answer is 0.3. Okay? So there, that's a terminating decimal right there, 0.3. And the final answer is, well, we don't forget, like we did last time, with a 3 here. So the final answer is 3.3. We add the 0.3 to the 3. If I read it out, it would be 3.00 plus 0.3. Here's the plus at 3.3. And you can bring down the 0 if you want, but this problem doesn't call for that extra 0 in the hundredths place. So let's do this one here. We have 3 divided by 5. 3 divided by 5. Right off the bat, I'm going to put a decimal point there and a 0. Does 5 go into 3? No. 0. Does 5 go into 30? Yes. How many times? 6. Okay. 5 times 6 is 30. 30 minus 30 is 0. We're complete. The answer is 0.6. Okay, and over here, just to make it the same, 3.3. Okay, example 2. Writing a fraction as a repeating decimal. In a repeating decimal, the same block of digits repeats infinitely many times. The block of digits that repeats can be 1 digit or more than 1 digit. So, write each fraction as a decimal. State the block of digits that repeats. And we state it by putting a line on top of the repeating digits. We'll see that here shortly. So, we're going to say 2/3. Well, the slide previous said divide the numerator by the denominator. Okay, to convert to a decimal. So, we're going to do that right now. We're going to say 2 divided by 3. And I'll get started by putting a little extra here for us. So I'll put the decimal point in because I know we're going to have one. 3 goes into 2 0 times. Okay? 3, so that's 0. So 3 goes into 20. How many times? 6 times. 6 times 3 is 18. 20 minus 18 is 2. Bring down the 0. 3 goes into 20 how many times? 6. 6 times 3 is 18. 20 minus 18 is 2. And you see how, bring down another 0. We're going to divide again. It's going to be another 6. And on and on and on and on. So this will go on forever. This little pattern will go on forever. So what is repeating here? The thing that repeats is the 6. Over and over and over. So our answer is 0.6 repeating. That's the answer here. So now let's try this one. This is a little different. This is an improper fraction. We're going to go ahead and do the same thing though. We're going to take the numerator. Let's try, we'll take the numerator, 15, and we're going to divide it by 11, the denominator. And what do we get? So 11 goes into 15, yes. How many times? 1 time. 1 times 11 is 11. 15 minus 11 is a 4. We got a decimal point right here. A decimal point right here, and we're going to have to, since there's a remainder of 4, we have to bring down the 0. I just added the 0 up here, so up by the 15.0 now. 11 goes into 40 3 times. 3 times 11 is 33. 40 minus 33 is 7. We need another 0. We're going to bring another 0 down. Okay, 11 goes into 70 6 times. 6 times 11 is 66. 70 minus 66 is 40. Bring down another 0. Add a 0. Bring down a 0. 40 divided by 11 is 3. 3 times 11 is 33. 40 minus 33 is 7. Bring down another 0. 11 goes into 70. 6. Well, we've gone far enough. This pattern repeats. So we have 1.36363636 forever. So our answer here is going to be 1.36 with the 3 6s repeating forever. Okay, example 2. Let's check your understanding. So as before, stop the video and do these on your own. And then when you come back, we'll do them together. But it says here, write each fraction as a decimal. State if the decimal is terminating or repeating. If it repeats, state the block that repeats. So you go ahead and do them, and I'll wait. Okay, now that you're back, we're going to go ahead and start with A. So A says 7/9. So how do we do this? We take the numerator, 7, and we divide it by the denominator, 9. So 7, can 9 go into 7? No. I'll just put the 0 there because I'm going to have a decimal point. I'll put a decimal point here and a 0 here. 9 go into 70? Yes. How many times? 9 goes into 70 7 times. 7 times 9 is 63. 70 minus 63 is 7. Add a 0 here. Bring down the 0. And again, 9 going to 70. Yes, 7 times. Okay. 7 times 9 is 63. We're going to subtract 63 and we're going to get a 7. Bring down another 0. You see the repeating pattern? Yes, you do. So the answer here is 0.7 repeating. Because this for 7 will go on, the 7s go on forever. Okay, how about this one? 21, 22, 20 seconds. So 21 divided by 22. Okay, so 22 going to 21? No. So I could put a 0 right here. And I know I'm going to have a decimal point right there. I'm going to have a decimal point right here, and I'll put a 0 here. So now I have 210. 22 goes into 210? Yes. That goes in 9 times. 9 times 22, 9 times 9 is 18. 18, carry the 1, 18, 19. So 210 minus 198 is how much? 12? So does 22 go into 12? No. I'm going to bring down a 0. I got to add a 0 and bring down a 0. Okay. So now does 22 go into 120? Yes, it does. How many times? Well, 5 times. So 5 times 2 is 10. Right there. Carry the 1. 5 times 2 is 10. It's 11. 110. 20 minus 110. 120 minus 110 is 10. Bring down a 0. Okay. Now 22 goes into 100 how many times? It goes in 4 times. I write the 0 here that I brought down. 4 times this is 4 times 20 is how much? 80. 4 times 2 is 8. So it's 88. Okay. 88 is 12. Bring down the 0. So now we're back to the 12 right here. So now we're doing the same thing over and over again. We repeated. We're back to the 12. We're going to get the same pattern over and over. So that means you're going to have a 54. 54. So the repeating pattern is the 54. So the answer is 0.954 4, and the 54 is the repeating piece. Okay? 11 eighths. So we're going to take 11 and divide it by 8. And we're going to, 11 goes into 8 how many times? 1 time. 1 times 8 is how much? 8. 11 minus 8 is 3. Decimal point, add a 0, bring down a 0. 8. 8 goes into 30. Couldn't see what I was looking at here. 8 goes into 30 how many times? 8 goes in there 3 times. Right? So 3. 3 times 8 is 24. 30 minus 24 is 6. Bring down a 0. 8, add a 0 here. 8 goes into 60 how many times? Carry that out. 7 times. 8 times 7 is 56. 60 minus 56 is 4. Bring down another 0. 8 goes into 40 5 times. 8 times 5 is 40. 40 minus 40 is 0. Case closed. This is a terminal decimal. It terminates right here at 1.375. And you know that because the remainder at this point was 0. Okay? Now the last problem is 8. We flipped it. This was 11 divided by 8. This one's 8 divided by 11. So we're going to do this. We'll see how this works out. We're going to take the numerator, 8, right here, 8, and divide it by 11. I'll carry this out a little bit further. I'm going to put a decimal point right there because I know we're going to need it, and a 0 actually. I know we're going to need it. So 11 goes into 8 0 times, and that's why I knew we needed it. 0 times 11 is 0, so bring down the 0. So we added a 0 here and brought it down. So 11 into 80 goes how many times? 11 goes into 80 7 times. 7 times 11 is 77. Okay, 77. 80 minus 77 is 3. Add another 0. Bring down another 0 here. 11 divided by 30 divided by 11 is 2. 2 times 11 is 22. 30 minus 22 is 8. Okay. Bring down the 0. And guess what? We look back up here. We divided into 80 right here, up here in the very first time. Here's an 80. So the same pattern is going to repeat again. So we can do that. 11 divides into 80 7 times. There's our 7. 7 times is 77. Minus 80 minus 77 is 3. Bring down a 0. 11 goes into 30 2 times. So as you can see, it repeats. Okay? So our repeating number is the 72. So the answer here is 0.72 repeating. Oh, I shouldn't have done that. I made it too long. Sorry. Too long. I'll go this way with it. There. 72. 0.72 repeating. Okay, for example 3, it's ordering fractions and decimals. So when you compare and order decimals and fractions together, it may be helpful to first write the fractions as a decimal. So write the numbers in order from least to greatest. Well, the first number we have is a quarter. Well, to write a 1/4 as a decimal, we're going to take 1 and we're going to divide it by 4. We're going to put a decimal point here. We're going to put a 0 here. 4 goes into 1. Nope. 0 times. So we're going to put a point. 0 times 4 is 0. 4 bring down is add a 0. Now we're going to do 4 into 10 goes yes. Goes how many? 2 times. 2 times 4 is 8. 10 minus 8 is 2. Add another 0. Bring down the 0. 4 goes into 20 5 times. 5 times 4 is 20. 20 minus 20 is 0. Okay, so the 1/4 is 0.25. Then we have a minus 0.2, and then we have a minus 3/5. So 3/5, I'll write that one over here, is 3 divided by 5. So, and we're going to put a decimal point and a 0 because I know we're going to need it. We're going to put a 0 here because 5 doesn't go into 3. 5 goes into 36 times. 6 times 5 is 30. 30 minus 30 is 0. Case closed. Minus, it's 0.6. 0.6. And then the last one is 1.1. So now if we order them, these two negatives are going to be at the far left side, and the two positives will be at the far right side. 0.25 is smaller than 1.1, and negative 0.2 is larger than negative 0.6. It goes closer to 0. So it's going to be like this. It's going to be negative 0.6. Then it's going to be negative 0.2. Then it's going to be 0.25. And then it's going to be 1.1. Okay? So there we ordered them now. So now you know that the quarter is over here. This is the 0.6 is the negative 3/5. So if we did it, would be the negative 3/5 minus 0.2, and then it's the 1/4, and then it's the 1.1. That would be the order of those fractions. Okay? Okay, example 3. Check your understanding. Order from least to greatest. Well, just like we did in the last slide, they want to take these 4 fractions or decimals and put them in order from least to greatest. And this is a check your understanding, so why don't you go ahead and stop the video, pause it, and try these on your own, and then when you come back, we'll do them together. Okay, now that you're back, let's look at problem A. So we have 0.2, so we have the decimal of 0.2. We have a fraction 4/5, we have a fraction 7/10, and we have a decimal of 0.5. So what is the value for the fraction that's 4/5? Well, we can do that right now. We can say 4 divided by 5. And that is, oh, this is really terrible. Excuse me. I don't know what's going on here, but this is crazy. I want to move over a little bit. There's something not writing correctly with my pad right now. So I'm going to move over a little bit. I'm going to say, up here, I'm going to say 4 divided by 5. And I'm going to put a 0 in here because we know 4 is smaller than 5. We're going to decimal point here. We're going to do some preparatory work. So 5 goes into 4 0 times, so here's the 0. 5 goes into 40. We added a 0 here after the decimal point. 5 goes into 40 how many times? 8 times. 8 times 5 is 40. 40 minus 40 is 0, so we are done. 0.8 is the value for the 4/5. And then for the 7/10, we have 7 divided by 10. And we know we're going to have a decimal point here, and a decimal point here, and a 0 here, because 10 does not go into 7. So we're going to 10 into 7 is 0. 10 into 70, because we added a 0, is 7. 7 times 10 is 70. 70 minus 70 is 0. Okay, so we now know that we have 0.2. We have 0.8. That's for the 4/5. We have, for the 7/10, we have 0.7. And then the last one we have is 0.5. Now we just have to put them in order. So what's the order? Well, these are all positive, so they're above 0. So the smallest number is the 0.0. So we're going to do the 0.2. And then the next one is the 0.5. 0.5. And then the next one is the 0.7. And then finally it's the 0.8. That's the order right there. And if we want to write them, then it's going to be the 0.2, 0.2, comma, and then we need the 0.5, which was here, the 0.5, and then comma, and then the next one is going to be the 8, and then the 7, so the 7/10, 7/10, and then the 4/5. Okay, so now let's try this other one. Same thing. So that's our solution over here, right here, using the original numbers. So going for B, we have a negative 1/8 and a negative 1/8. We're going to start with that right now. I'll do the 1/8. So 1 divided by 8. You're going to add a 0 here. We're going to put a 0 in front because 8 does not go into a 1. We had to add the 0. So 8 goes into 10 one time. 8 times, what is it, 8? 10 minus 8 is 2. Bring down another 0. Here's our other 0 right here. 8 goes into 20. How many times? 2 times. 2 times 8 is 16. 20 minus 16 is 4. Bring down, add a 0 here. Bring down another 0 here. 8 into 40 goes 5 times. 5 times 8 is 40. 40 minus 40 is 0. We have now complete. So the 1/8 is 0.125. And then the next one we have to deal with is the 1/4. Well, we did the 1/4 over here before, didn't we? Oh, no, we did not. Sorry, wrong. The other problem. So 1/4, and we'll do the math on that one, is 1 divided by 4. And so that is going to be a 0 here, and a decimal point, and a decimal point, a 0. 4 goes into 10 2 times. 2 times 4 is 8. 2, bring down, 10 minus 8 is 2. Bring down a 0. Here's another 0. Okay, so we're going to 4 into 20 goes 5 times. 5 times 4 is 20. 20 minus 20 is 0. So 0.25. So the next, so we have the 0.8, the 0.75, the quarter, it's negative. Oh, and the 1/8 was negative. Negative here. And then we have the negative 0.75. And then we have a negative 1/4, which is the 0.25. And then we have the negative 3.75. So this was the 1/8 one. This one was the 1/8 right here. Okay, so putting them in order, the number closest to 0, since these are all negative, the one closest to 0 is going to be the largest number. So closest, we have 0.125, we have 0.75. Well, 0.1 is closer to 0. 0.125 is closer. And so the closest to 0 we're going to have the negative 0.125. That's way over here on the left. Then the next one in is the 0.75, a quarter. Well, it's going to be the 0.25. So it's the negative 0.25 right here. And then we're going to take, and the next one in order is the 0.375, because then there's the 0.75 is all the way on the the left-hand side. So now we're going to have negative 375, and that's a point. I put that decimal point here in the wrong spot. And then it's the 0.75. That's the farthest negative, farthest to the right, or left rather. So the 0.75 is the number. So it's negative 0.75. And then the next one in line is the 375. That's the number itself, 375. So negative 0.375. And then the next one in order is the 0.125, which is the 1/4, so it's negative 1/4. And then the last one is the negative 1.125, which is the negative 1/8. And that's our order on those. Objective 2, writing decimals as fractions. Reading a decimal correctly provides a way to writing the fraction. So let's look at this. So we have the decimal in one, then the way we read it, and then how we write it as a fraction. So we start off with the decimal part, which is 0.43. Well, the 0.43, if you read it as 43 hundredths, 43 100ths, 43 hundredths, you can look at the fraction as, right here, 43 hundredths. That's pretty simple. 43 hundredths is 43 hundredths is 0.43, 43 hundredths. So if a decimal is greater than 1, you can write it as a mixed number. You can say 1 and 43 hundredths, or however you want to, if you have to, you can just divide it out. Okay? Good. Okay, example 4, writing a decimal as a fraction. So it says write 1.12 as a mixed number in simplest form. So we're going to take this, just the piece, because the 1 is fixed. We don't have to worry about the piece that's the 1 piece here. We don't have to do anything with that. We're just going to keep it. So if I write the final answer over here, I'm going to say 1, okay? And then it's going to be some fraction. We're going to end up with a fraction here. Instead of the 0.12, we're going to end up with a fraction. So I'm going to put a little dash here. So now we take the 12th, 1.12. So we just take, we can take the 0.12 and divide it by 100. Okay, and what does that equal to? Well, we can, to find the lowest terms here, we can take 12 can be divided by 4, and 100 can be divided by 4, right? We can divide both of them. And what do we end up with then? We end up with 3 over 25. Okay, so we simplified this fraction 12 100ths by dividing the top and the bottom, the numerator and the denominator, by 4, and we ended up with 3 25ths, and that's our fraction now. So our mixed number now is 1 and 3 25ths. There's our fraction, our mixed number. Okay. Okay, for example 4, checking your understanding. We want to do the same as we just did in the previous slide. Write as a fraction or mixed number in the simplest form. So if we take now A is like 175, you're going to do the same thing we just previously did. So go ahead and try these on your own. When you come back, we'll do them together. Stop the video and we'll come back. Okay, now that you're back, let's try A. So like I did before, I'm going to pull the 1 aside because we don't have to do anything with the 1. So I'm going to leave the 1 right here, and I'm going to put a dash for my fraction. And I'm going to say 0.75, so 0.75, or I'll just do the 75 now, 75 divided by 100, because that's what this is, 75 100ths, it's now a fraction. Case closed, except this can be reduced. And how does it get reduced? Well, we can divide both sides by what? We can divide each side, the top and the bottom, by 3 or 25, right? 25. So if we divide the top by 25, we get 3, and the bottom, the denominator, by 25, we get 4. So our answer here is 1 and 3/4. Okay, how about 2.32? Well, let's try that one. I'm going to put the 2 right here, and I'll put a dash. And we're going to put the fraction in this part. We're going to take 32, and we're going to divide it by 100. Well, so we can divide. So if we divide the 32 by 100, what are we going to divide that by? If we divide, well, it looks like we can take and put a 4. If we put a 4 into 32, we're going to get an 8. And 4, we're going to get a 25, right? So if we divide the numerator by 4, and we divide the denominator by 4, we're going to get 8 25ths. Okay, so the answer is going to be 2 and 8 25ths. You see that? It's easy. You just put the 100 under it and reduce the fraction to its simplest form. Okay? Here, let's try this one. 0.65. So now there's no 1 like we did to add, or a 2 or whatever we had that we were putting in front, right? So it's 0. So we're going to take 65 and divide it by 100. Well, we know right off the bat that 65 is, in terms of fives, because it's divisible by 5, and this is divisible by 10, so they're both divisible by 5. We know that. So 65 is going to be how many 5s? Well, it's going to be 50. 10 would be 50, plus 3 is 13. So this is going to be 13, what? Over, how many times does 5 go into 100? 20 times. 13 20ths. Okay, so our answer here was pretty fast and simple. It came out at 13 20ths. Okay, example 5, writing a repeating decimal as a fraction. It says, write the repeating decimal, 0.72, as a fraction in simplest form. Okay, well, this is a procedure that you kind of have to follow to do this. So watch and we'll go through it. So the first thing I'm going to do is I'm going to define the 0.72. I'm going to define it as n equals 0.72. Okay, repeating. Okay, so now I'm going to multiply both sides by 100, because in order to take this 0.72 to make it an integer, you have to multiply by 100, and it'll be then 72. Okay, so I'm going to say 100 times n is equal to 100 times 0.72 repeating. And that's going to be 100 n is going to be 72.72 repeating. Okay? Now you see I multiply this by 100. Now I have an integer value out here. So now the n is equal to 0.72 repeating. And this is equal, this is equal to 0.72 repeating n. And here's 0.72 repeating right here. Okay? So I want to get rid of this piece. In order to do that, I'm going to subtract n from 100n. So when I subtract n from 100n, so here's n, so minus n minus 0.72 repeating. Okay? So now I end up with, when I do this, I end up with 99n is equal to 72, because now the 0.72 repeating and this 0.72, they cancel each other, so we're left with 72. So 99n is equal to 72, and then we divide both sides by 99, divide by 99, divide by 99, and we get n equals 72 99ths. Okay, and so now what is 72 divisible by 3? What are we going to do here? Well, if we put, as a matter of fact, if we take 79, 9 times 8 is 72. So we're going to reduce this down to lowest terms. 72 is going to be 72 divided by 9 is 8. I'm going to do divided by 9 here. And 99 divided by 9, okay, you get the picture. So 8 divided by 11, because 99 divided by 9 is 11. 72 divided by 9 is 8. So the answer here is, well, I'll write it up here, 8/11. Okay, that is the repeating decimal of 0.72 repeating, written as a fraction. Okay, example 5, and check your understanding. I think this is going to be 2 slides, but that's okay. We're going to work through them. So what they want us to do is the same thing we just completed. Write each repeating decimal as a fraction in simplest form. Okay. Well, let's start. Oh, this is yours. So you do it. Stop the video. And when you're done, come back and restart the video, and we'll move on from there. Okay, now that you're back, let's go ahead and give it a try. So what did we do before? We started off, we said n is equal to the repeating decimal part. N is equal to the 0.7 repeating, right? That's what we started off. And then we know that we're going to multiply the n on both sides because we need to get the repeating part to be an integer. Well, in this case, it's 10. If we multiply 0.7 by 10, it'll be 7. So we're going to get 10n is equal to 7.7 repeating. Okay, you see how we just shifted one of those 7 repeating 7s out, but we still have the repeating 7s because they go forever. They go forever, so we can multiply by 10, get our integer, and still have all these repeating 7s forever. So now we want to subtract the n from the 10n. So now we say minus n equals minus n equal, we're going to say 0.7 repeating. We're going to subtract them, right? That's the repeating. So now we have 9n is equal to 7. The 0.7 repeating, they disappear. So dividing both sides by 9, we get n equals 7/9. And you can't reduce that any further. That's as far as it'll go. Let's try this one here, 0.54. So just the same way, we're going to write an n, and it's going to say is equal to 0.54 repeating. Then we're going to, we have to multiply, this is a hundredth, right? A hundredths. So we have to multiply by 100 to get this to an integer. So 100 n is equal to 54.54 repeating. So we can subtract the n from the 100n, and we end up getting, so if we subtract n minus 0.54 repeating, here's the subtraction, we get 99n is equal to 54. Okay? And then if we divide both sides by 99 divided by 99, we get n is equal to what? Well, what goes into 54? And you get with 9s here, right? So what 9 times 6 is 54. So 9 times 6, so we can divide the 9 into the 54, and we'll end up with a 6, and that equals 6. And the 9 goes into 99 11 times. So the answer is 6 right here, 6/11. 6/11. Okay? See that? Okay, example 5, check your understanding. Well, we're going to do another, just as the previous slide, because there were 3 problems to do. So again, stop the video, try this one. It's a little harder, a little longer maybe. Try it, and when you come back, we'll do it together. Okay, now that you've had time to do that, you're back. Let's give it a shot. So we know right off the bat, it's simple. Remember, as I've said all along, it's just process. Remember what you have to do and just repeat it. In this case, we're going to write an n, and we're going to say it's equal to 0.213 repeating. Okay? And then we have to look at this repeating section here and figure, what do we have to multiply this by in order to get that, for that to become an integer? So we're going to multiply by 1,000, because these are 213 thousandths. So 1,000 n's equals 213.213 repeating. So now the next step in the procedure here, the process, is to subtract the n from the one n from 1,000 n's. So when we do that, we're going to say minus n is equal to minus over here 213. Okay, so now we're going to subtract that, and the answer here is going to be 999 n's is equal to 213 because you see this, remove this, we deleted this repeating piece. So now we have 999 divided by 213. So divide each side by 999. 999. And we end up with n being equal to 213 divided by 999. Now this might look difficult, and it is kind of difficult because you have to try to factor this and figure it out, right? But I can tell you by looking at it, 210 would be 3 70s, right? 3 will go into 21 7 times. Oh, and I see there's 3 here. So I can say that this 3 will make a 171, right? So we're going to divide each side by 3. So because this will give us a 7. If I divide the 21 or the 210 by 7, I get a 70. And the 3 divided by 3 gives us a 1. So the answer here is going to be 71 divided by 333. Because both of these had a factor of 3 hidden in them. And 71 is a prime number. You can't reduce this any further. 71 is prime. Okay, and that finished this section.